for joining this session. My name is Rohini Gaonkar. I'm a senior developer advocate, and in this session, we will learn about how we can increase our application availability with AWS observability solutions. We will start with typical challenges our customers face and why observability is important. We will also look at some of the AWS tools and dive a little deeper into Amazon CloudWatch Service Lens with Amazon CloudWatch and AWS X-Ray. And of course, some interesting demos towards the end to get you started. Let's quickly take a look at a scenario of some kind of failure in our system. We come into the office blissfully ignorant and suddenly an alarm goes off, causing some confusion as to what is happening. As time passes by, we start to get a little stressed, and typically we do some internal investigation that usually creates a false sense of hope. Fixes we implement aren't working, so we get desperate until someone figures out the root cause. And finally, we go back to the sense of enlightenment as we have a resolution and we go back to being blissfully ignorant. This could be few hours, few days, or even weeks depending on the issue we are facing. While reactive monitoring tools are fairly easy to implement and maintain, they are most useful only after an issue has occurred. There will always be issues. The goal here is to make this loop as quickly as possible, and a good observability plan will keep the cycle quick. It's important to understand why we are talking about this, why evolution of monitoring is required. At a high level, today's systems are increasingly more difficult to understand. For years, we have talked about breaking down the monolith into microservices, and this shift should also apply to our monitoring systems. Because monoliths were just few servers where it was easy to monitor it. Now you have tens and hundreds or even thousands of microservices to maintain. Those resources that hosted monoliths would live for months, if not years, but our microservices are short-lived, stateless resources. And more devices creating more data means more humans to look at it. Cloud has enabled us to collect data from these different endpoints. And of course, change is the only constant. We are constantly building and deploying newer versions of our application for better customer experience. So let's look at the three things that are foundation of an observability plan. Metrics are numerical representation of data measured over time and useful for identifying trends and prediction. So if a resource is unhealthy, metrics show the trend and may allow you to predict when a node becomes unhealthy. Logs are immutable records of an event, useful for emergent and unpredictable behavior. If a resource is unhealthy, a log is going to help answer why it became unhealthy. And while logs and metrics are system-centric, traces are user-centric. They provide the visibility into the path traversed by a user, which helps understand a path a request takes or the flow that it takes. So if a resource is unhealthy, traces will tell you the impact it has to the user or the request path. And all of these are equally important and key components of observability. Speaking in more AWS-specific terms, these are the services and features that provide AWS observability tooling for metrics, logs, and traces. The two key important services are Amazon CloudWatch and X-Ray. Let's look at each. Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications that you're running on AWS. You can use CloudWatch to collect and track metrics, collect and monitor logs, and set alarms. You can gain system-wide visibility into your resource utilization, your application performance, and operational health. It easily integrates with a lot of AWS services and your third-party solutions. You can create alarms to monitor your CloudWatch metric in your account. So for example, you can create an alarm on EC2 instances CPU utilization, or an ELB request latency, or even charges in your bills of AWS. You can also create alarms on custom metrics that are specific to your custom applications or infrastructure. When you create an alarm, you can configure it to perform one or more automated actions when the metrics you choose to monitor exceed a threshold you define. Now in the upcoming demo, we will see how to set these notifications and actions. To get started with monitoring, you can use the automatic dashboards with pre-built AWS best practices and explore your account resources, view metrics, and alarms. Automatic dashboards remain resource aware and are dynamically updated to reflect the latest state of important metrics and of performance. You can now filter and troubleshoot to a specific view without adding additional code to reflect the state of your resources. And once you have identified the root cause of performance issue, you can quickly act by going directly to that AWS resource. CloudWatch logs can monitor your logs in near real time for specific phrases, values, or patterns. So for example, you can set an alarm on the number of errors that occur in your system logs. So you can then view the original log data to see the source of the problem itself. And the log data can be stored and accessed indefinitely in the highly durable, low-cost storage, so you don't have to worry about your hard drives filling up. With X-Ray, you can understand how your application and its underlying services are performing to identify and troubleshoot the root cause of performance issues and errors. It provides end-to-end view of the request as they travel through your application and shows a map of your application's underlying components. The user-centric model of X-Ray enables you to create a user-centric picture of requests as they travel across services and resources. By correlating and aggregating data on your behalf, X-Ray enables you to focus on improving the end-user experience of your application. So with X-Ray, you can create a service map of your application, view different connections, create a dependency tree, detect latency, bugs and errors, and also build your own analysis and visualization using X-Ray records. A trace is a set of data points that share the same trace ID. So for example, when a client makes a request to your application, it is assigned a unique trace ID. As the request makes its way through your services in your application, the services relay this information regarding the request back to X-Ray using this unique trace ID. So to provide a performant and cost-effective experience, X-Ray does not collect every request that is sent to your application. Instead, it collects data for a statistically significant number of requests. Hence, X-Ray should not be used as an audit or compliance tool because it does not guarantee data completeness. You can use X-Ray with applications running on AWS services like Amazon EC2, Lambda, SQS, SNS, and Elastic Beanstalk. In addition, X-Ray SDK automatically captures metadata for the API calls made to AWS using the SDK itself. We will see both the ways and the benefits of using SDK in the upcoming demo. Now that we have talked about these services, CloudWatch and X-Ray that provide us the logs, metrics, and traces, it is important to note that each provide their own rich insights and analytics features as well. However, we still have to understand how we can use them together to get a 360-degree view of our problem, how to correlate them to get deeper insights, and how we can use this information, which are foundation of deriving the observability. Because our goal is not just to collect them, our goal is observability and how observable is our system to quickly resolve issues. So going back to the slide, we want to reduce the length of that cycle. The three pillars, metrics, logs, and traces, produce the most value when you can correlate them. So, while they have their own unique purposes, in unison, they provide maximum visibility of the system. Speaking in more AWS-specific terms, these are the services and features that provide the AWS observability tooling. Don't worry, you won't have to use all of these services and tools. You can find more information on these tools depending on the use cases that you're looking for. So for example, if you're looking only at container or Lambda deployments, then look for the specific insight tools. Or use Amazon CloudWatch Synthetics, a fully managed service that enables you to create canaries to monitor your endpoints and APIs from outside in. Or if you want a holistic view of your applications, then look at Service Lens feature of CloudWatch. It enables you to visualize and analyze the health, performance, and availability of your applications in a single place. And we will look at this service in the upcoming demo. CloudWatch Service Lens enhances the observability of your services and applications by enabling you to integrate traces, metrics, logs, and alarms in one place. It enables you to gain visibility into your applications in two main areas. Infrastructure monitoring, using the metrics and the logs to understand the resources supporting your application, and transaction monitoring, using the traces to understand the dependencies between your resources. So let's look at that demo that we all have been waiting for. In the demo, we are going to look at Amazon CloudWatch Service Lens with X-ray integration. We have already deployed a sample app which has one endpoint and two Lambda functions, one to put items into the DynamoDB table and the other to get items from the DynamoDB table. The sample code is available at this GitHub location with the steps on how you can deploy this and make the get and put requests. So in the sample app, the template or the SAM template that I have defined has tracing enabled for the API and tracing enabled for the two Lambda functions that we have defined. And in the code, we have not imported the AWS X-ray SDK because that is the second part of our demo. In this code, we have defined a DynamoDB table and we have defined two functions. One is get items and put items. Put is to put items in the DynamoDB table and get is to get items. But here, notice I've also defined a random exception, which is almost 50% of the times our function should send a fake error to our API. And I've also defined the handlers for get and put functions. Now this has already been defined, so let's go ahead and make some calls to the APIs. The makes calls command that is already been created just adds 20 items into our DynamoDB table and does 2000 get requests on this particular function. So if you go back to CloudWatch in the AWS console, you can notice that on the left side, on the navigation pane, you can check out the different alarms, the logs, the metrics that are incoming that can be viewed individually, or you can look at all of them together in Service Lens. And as mentioned in the presentation, if you want to just dive deep into the container insights or Lambda insights, you can also check them out here. And of course, we also talked about synthetics as a feature. Let's go ahead and click on Service Map. So in this case, you can see the circles or the nodes represent the distributed resources in the application that have had the tracing enabled. Currently, this is in the requests mode. So in the request mode, the larger circles here indicate higher number of trace requests going to these services. Similarly, the thicker the nodes, connections or edges signify the higher number of trace requests going between these different nodes. Now, if I change this from request to latency mode, let's see what happens. So now if you see, the more latency is actually coming from our put item function handler rather than the put item itself. So let's go back to the request mode. You can also see the map legend where if there are faults or 500 errors for the server side, they will be represented in red. The 400 errors for client errors will be represented in orange, throttling errors in purple, and other legends for looking at this particular map. If you want to look or want to filter this quickly instead of the map view, click on the list view. And you can see all the nodes and you can quickly go ahead and dive deep into the nodes that you're looking for. Let's click on API Gateway display stage. Now I can either look at the logs directly for this particular stage or I can look at traces. Click on View Traces. In the view traces section, you can see you can now add filters to all the traces that X-ray has collected. So here I can either filter based on the status that I received, like OK, fault, error, or I can also filter based on the HTTP request that I've received. So let's go ahead and check out the GET request, add that to the filter. So now I've added HTTP method for GET request. Let's go down. It has found 121 number of traces that match the filter. The orange markers here show that the requests in this part of the distribution are slower than the 99% of those making up the majority of the requests. So let's filter further and to show only traces associated with these long response times. So now it would only find 6 traces that match this filter. Here you can see all the traces that have the response time higher and match the filter that we gave, and you can also find more information by clicking into the trace icon. Send the request to Lambda. Lambda took how many milliseconds for the context, how much time did the function actually require. So here, initialization represents the time spent loading your function and running the initialization code. This subsegment only appears for the first event processed by each instance of your function. The invocation represents the work done by your handler code. We will be instrumenting this code further and check what happens here. And finally, the overhead represents the work done by your Lambda runtime to prepare the handle for the next event. So we can then go further below and check out if there are any annotations or metadata for this particular API. And below, last but not the least, you can find the logs associated with this particular request that we have filtered into. So if I want to debug further, I can go ahead and check out more information as to what was happening here, and if there was some issue, I can then further go ahead and troubleshoot that issue. So now that we have covered the basics of how this looks in service map, let's go ahead and check out instrumented tracing using the X-ray SDK. So back in our code, I will show you open the next folder for the X-ray instrumented demo. In this, I have now added the AWS, or I have now imported the AWS X-ray SDK. I'm patching everything that is happening in this particular function. I've also added code for the X-ray recorder to capture what is happening inside the function. And this will capture everything that has been happening. So even if I don't explicitly ask it to capture DynamoDB, because the function has been talking to DynamoDB as a service, it will also start capturing that. So let's go and make some calls in this function. I'm just going to make some calls again for this particular deployment. Great. So let's go back to service map, and here you can now see that the new application is now visible that we have deployed. So everything looks similar, but hey, now we also have a DynamoDB table. Let me go back in time a little and show you both of them side by side. So this was the older X-ray demo, or the first part of the X-ray demo, where there was no DynamoDB that was traced. And in the second part, you can now see that DynamoDB can be traced into this function. So let me quickly also check you how this sees. So here you can see the CloudWatch metrics as well. If I want to go ahead and add any alarms, I can also do those. I can just click on View Matrix, and this will open up in a separate window where I can now see more information about this particular metric. I can go ahead and add more metrics if I need into this particular graph. I can go ahead and check for anomaly detection for this particular metric. and I can also go ahead and add more alarms. So let me go ahead and show you how to add an alarm. Once you click on that bell icon, you can go ahead and say anything that is more than 20 for one data point. If this goes beyond 20, even once, just send me an alarm to an SNS topic. Now, a simple notification service topic could be an email notification, could be an SMS, could be an action that you want to define as well. You could do that in these cloud watch alarm. And once you define this cloud watch alarm, it will also start looking at that data and send you these notifications before the issue actually happens. Back in the service map, let's click on view traces for the for the put filter, and we will also go and check just the first trace of this. Now here you can again see that the entire thing is going till DynamoDB, and it took the duration of 916 milliseconds. So in the segmentation, these are the similar segments that we saw before. Now we can find more information here in the invocation section. Here, because we have used the SDK for X-ray, we can now expand as to what is happening in this particular invocation. There's a put handler that is calling put item, which is further going and adding data into a DynamoDB table. And we can also see how long it took for it to go ahead, add that data into DynamoDB table and come back. So if I want to do more optimizations, I can now understand what part of my code is taking longer and do further performance optimization. If I scroll further, I can also check out the logs for this particular execution and what is happening, or what are the errors that are causing this issue. Now let's go and check out the third part of our demo, that is adding annotations and metadata to our instrumented code. Now in the sample code that we just saw, I have also added something. I have also added code that will put annotations for this, put annotations for the key name and the value name as well. Now, annotations are key values that are associated with the traces and are indexed by AWS X-ray. So you can use them to filter the different traces, and you can also create trace groups to slice and dice your transactions. In the same place, you can also add something called as metadata. Metadata are also key values that are associated with your traces, but they are not indexed by AWS X-ray. So you can use them to add more additional context for any operation using any native object. So now, because I've added this to both of my functions, so let's go and check out the trace in view traces. If you scroll further down, you can now see there is a new filter key added as name, and which can have multiple values depending on the code that I've defined. So here, if I want to dive deep into what happened with thing 4, I will click that, add to filter. And now I can filter all the requests that were associated for this particular thing 14 that happened with my code. And I can further dive deep into this issue. So in this case, let me go ahead and show you one of the faults. So the similar way that we saw in the previous example, but here there is no DynamoDB. What happened with our code? Now, compared to the first one when we had not done any instrumentation, to this one, you can now go deeper into what is happening. Here, the get and get item, you can also see who's causing this problem. Where is this fault coming from? And if this was a real world scenario where you had certain error, you could also go ahead and check that out in the logs that are being showcased below. So let's summarize our discussion. AWS observability tools provide purpose-built features that allow you to easily identify issues, quickly improving your application's availability. You can correlate logs, metrics, and traces for deeper insights. With help of AWS and our supported third-party tools, you can easily set up and maintain observability of your application, and it can lead to automatic potential root cause identification. If you are interested to dive deeper into the AWS observability features, do check out the workshop at observability.workshop.aws. Accelerate your cloud journey by checking out the featured courses to build your cloud skills on AWS. Or visit the link below to explore the digital training courses that are provided for free. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take out the time to fill out our survey. Let us know what you think. Thank you again.